Hey guys, last little assignment video like this for Friday. So this is the last Friday of the semester. So this one is called the ideal gas law. So the last one was combined gas law. Keep all that separate because this works differently. This one's called the ideal gas law. So they're pretty similar. I'll give you a little word question. It's really just a sentence because I've shortened it so much since we're doing it online. It's just a sentence really. It's going to have, I think, 3 of these values. One of them is always given to you and you'll just solve for the unknown. It's a little easier than the last ones because you don't have to cross multiply or anything. It's a lot simpler of an algebraic equation to solve. So here's your formula. It's PV equals nRT. So your P is pressure, and we don't have any ones or twos. It's just you're only going to be given one pressure or solving for one. So P is pressure. It's going to be given to you always in the same unit this time, whereas last time they could change. And it's going to be atmospheres, little ATM, but we're not really dealing with them. Just know when you see it, kind of ignore it. V is volume, and it's going to be given in liters, but again, ignore the units. And T is temperature, which will be given in Ks. So same letters to represent these as last time. The difference here is that you have N and R, which are not in the last formula. N stands for number of moles, and don't ask me why they didn't just put M for moles or whatever. Just N is numbers of moles, and of course that'll be given to you, or you'll be solving for moles either way. And then R is what they call a constant. So that means every single question that you do, R has the exact same value. It's just the gas constant. So it's 0.0821. If you go on further in chemistry, there are a couple different versions of this with different units, but we're sticking to just one, keeping it simple for these online questions here. So 0.0821, its units are all of the other 4 units with it. So liters times atmospheres over moles times K. Again, though, don't just trust that all the units will work out fine, and you don't have to do any side conversions like you would do in like a higher up chemistry class, or even if we just had more time. So that's our units. Just accept that they will work out in your head and don't worry about them. So in these questions, like I said, you're going to be given 3 of these 5 values. And then R is always given to you. I'll put it in every single question just to like at the end of it, just to remind you of it. So that means 4 out of the 5 are given to you, and you'll just solve for the one that you don't have. So let me get my example here that we need. So here is the example, and it'll just be given to you on pretty much all of them look about the same. The way that you tell the difference in these and the last ones, like, because you have to do a little test next week for this, you see this R at the end. Well, I'm going to give it to you at the end of the question. So when you see that, you should know you're using this formula and not the P1V1 formula, okay? Because that one doesn't have an R, this one does. So same deal, you don't have to show this part, but I'm going to read through and assign these values, the numbers that go with them. A gas has a volume of 3.0 liters. So don't worry about the liters, but that tells us volume, which is V, equals 3. 3.0 if you want, but it's the same. A pressure of 0.9 atm. So that means pressure is 0.9. And a temperature of 398 K, which means T is 398. Okay. I'm not given N or R so far. How many moles of the gas are in the sample? And then here is your R equals value. So that means R is always at 0.0821. And we are not given moles, which is N. Okay. So that just means you'll solve for N. So you're just going to plug these numbers in this formula. On the left, you have P times V. So that's going to be 0.9. I'm going to do parentheses instead of writing times, but it's up to you how you set it up. You've done more math recently than I have. And then 3. So 0.9 times 3 equals N, which you don't have. So at this point, you can put an X, you can put an N. I usually just put N because that's the letter I'm solving for. But if you want to put X to make it more like what you're used to, go for it. And then, so it's N times R. R we have a number for, 0.0821. Times T, which is 398. Okay, So that's the only part I really need you to show for your work, is just show me you can set up this formula, and then you're welcome to just go ahead and put the answer, because some of us are comfortable just plugging that right there in the calculator and they can get in. And some of you need to write out your steps a little more. So of course I'm going to write the steps out so you know what the steps are. But you do it however you want. As long as you show that part that I'm pointing to right now, you're good. So basically solve it how you want, but we're getting n by itself. Okay, so I'm just going to go ahead and simplify my left side by doing 0.9 times 3. So that is 2.7. Let me do my little squiggly so we know it's separate. So 2.7, that's equal to n times the other 2. Now I'm going to go ahead and simplify these other 2 also, rather than rewriting it twice. So I'm going to do 0.0821 times 398. So that gives me something close to 32.7. I rounded it a bit just to go a little quicker. Okay, so all I've done, I left my n here. I simplified this side by multiplying those 2 numbers, and then I simplified this side by multiplying those 2 numbers. So I have 2.7 equals n times 32.7. So you need to get the n by itself. So a lot of times students get mixed up and they'll like do 32.7 divided by this, but we're trying to get n by itself. Okay, so I need to get rid of the 32.7. So to do that, I need to cancel this 32.7 out. And since it's technically on the top, I need to do a 32.7 on the bottom. But if you do it to one side, you got to do it to the other side, right? So 32.7 here will cancel out when we divide by it like that. So then I'm going to leave that. So then what I have here to solve is 2.7 over 32.7 equals n. So then all we need to do is divide 2.7 by 32.7, which will give me 0.08 for n. Now this is moles. It's okay if you don't write moles though, okay? And it's okay that it's that small. Moles are typically a pretty small number in these kind of questions. Now you're always gonna be solving, or most of the time be solving for something different, but it's no different when you do those. Like if I don't give you p, you'd have numbers here, you just get p by itself. If I don't give you t, you get t by itself. Whatever I don't give you and you have a little question mark up here for, that's what you're solving for, get it by itself. Okay, so this is the ideal gas law.